All right, so here we go. First of all, how do we know something is a function? You just know, huh? Okay, first of all, we know it is a function if the x values do not repeat. We know it is a function if it passes the vertical line test. That's very good. That is the pencil test. You are correct. So here is example number 1. Maybe they will give you a graph and they want to know if it is a function. So maybe the graph looks like this. Is that a function? No, it's not. Correct. Very good. Maybe they will give it to you in an equation form. Let's say something like Correct. Let's say y equals the square root of x plus 3. So if you were to graph this, it goes over 3 this way and does one of these deals. Is that a function? Yes, it is. Very good. All right, so what we just did is what you have to do for the first few. Piece of cake, right? Okay, I want to talk about domain. To find domain algebraically, there are 3 questions we ask ourselves. Well, 2 questions we ask ourselves. 1, is there an x in the denominator? That's the first question you ask yourself. 2, is there an x in a square root? If no to both, then your domain is negative infinity to positive infinity. If yes to number 1, x in denominator, set the denominator equal to 0 and solve. This is where x cannot exist. And last, if it is yes to number 2, x in a square root, set the inside greater than or equal to 0 and solve. This is your parameter. I mean, it's bounds, where it can be at. Okay? So, let's do one where we're finding the domain. Okay, no problem. No problem at all. I appreciate you saying something. Are ya? Dead. All right. Yeah. Yeah. No. Are you good? Okay. You're fine. No rush. I would never want anybody to get hurt. I got you.
Red means to slow his butt down.
Are we good? Yeah, cold front must come in. I have this one still open, but I think this one's okay. What? What are you looking for? Oh my gosh, you guys, there's no tornado. Here we go. I'm recording. Let's go. All right, here we go. Here is example number 3. Here's what you are doing for 9 through 15. Find domain. Then it's negative. Oh, well, we're going to get to actually one of those. Yes. Okay. That was a good question. All right. So let's say I have y equals x squared plus 7x minus 2. Is there an x in the denominator? Is there an x in the square root? So that means my domain is negative infinity to positive infinity. Okay. Let's say I have y equals 3 over x minus 1. Is there an x in the denominator? Is there an x in the denominator? So we're going to take that denominator, set it equal to 0, and solve it. What that means is that's the one place that x can't exist. So it technically does not equal 1. So we say our domain goes from negative infinity to 1, a u, 1 to infinity. Okay, how about this one? Y equals the square root of x minus 7. So, is there an x in the denominator? Is there an x in the square root? Yes. So we take what's inside the square root, and it has to be greater than or equal to 0. Can't have a negative under there, right? So now I solve for x. I'm going to go ahead and add 7 to both sides. I get x is greater than or equal to 0. If I was on a number line, oh, sorry, 7, my bad. My bad, I can't add today. X is greater than or equal to 7. So on my number line at 7, I'd have a closed dot, and it's everything that way. So my interval notation, that means that. My interval notation, that means that, is a bracket 7 to infinity. All right, so there are 3 instances. But what if, as Jackson pointed out, it's yes to both 1 and 2? All right, so let's try that one. Y equals, let's go, the square root of x plus 3 over x minus 1. All right, so first of all, is there an x in the denominator? All right, so we're going to start with that. We take the denominator, set it equal to 0, and solve. That's the one spot it can't exist. Is there an x and a square root? So we take what's inside the square root, set it greater than or equal to 0, and solve. All right, so on my number line, at -3, I would have a closed dot, and it's everything that goes to the right. However, where does it not exist? At 1. So at 1, I have to have an open dot. It can't be right there. So when I do my domain, I start at -3. I go to 1. We have to jump over 1 because it can't exist there to infinity. Correct. Cannot exist at 1. Yep. Back to here. All right, so just to kind of reiterate here. All right, so in the first one, listen up. In the first one, when we did this one, we said there was no x in the denominator and no x in a square root. So the domain was -infinity to +infinity. Number 2, we said there was an x in the denominator. So we set the denominator equal to 0 and solved it. That's where x cannot exist. In number 3, we said there was an x in a square root. So we took what's under the square root, set that greater than or equal to 0 because it has to be positive, and solved it. That gave us where it can exist. In the last one, we had both instances that we said yes to. So we had to do both of them. Okay? So lightning, I'll protect you. You're good. I will do whatever I can. You have to know I would do whatever I could to protect you. All right, so are we good? You're caught up, Marissa? We're good? Okay. All right. So is the question with domain at all? We've done. We're good with domain? Okay. Let's do the other side of that. If we do domain, we also have to do range. Okay, so let's talk about range. Range is your y value on a graph. It goes from the bottom to the top. And an equation. It is the overall value. All right, so for example, let's say I have a graph, and it's a parabola. If we're talking about the range, we always start from the bottom, and the first place that this parabola exists at is at -1. So this would start at -1 and go up forever to infinity. If it was from an equation, let's say y equals, what's a tough equation here? Y equals 10 minus x squared. If we were to graph that or think about it, the very highest this can be, if I put anything in for x, anything at all, what's the highest value we're going to get here? If I put 0 in for x, I get 10. If I put -1 in for x, I get 9. If I put +1 in for x, I get 9. So what is the highest value this function can be? 10. So this is actually going to be the highest part for my range. The highest it can be is 10. So what does that mean it's actually starting at? Yeah, very good. Negative infinity. Because everything is being subtracted from 10. 10 is the highest it's going to be. Then we'd have 10 minus 25, so you get negative 15, right? If you were to graph this in your graphing calculator, it would start up here at 10, and it's a negative x squared, so it'd be a parabola that opens down. So you can see that it starts at negative infinity, right? So any questions here? All right. So, next thing we need to talk about, see if we remember. We have words such as discontinuity. Discontinuity is where? Oh my goodness. Right. X cannot exist. We have removable. A removable discontinuity. Who remembers what that is? It is a factor that cancels and makes a whole. Do we remember that one? All right, how about non-removable? Non-removable is it doesn't cancel. And makes, what does it make if it's not a whole? How about a vertical asymptote? We got to get you back in the groove. Vertical asymptote. All right. Guys, focus. Oh, my goodness. All right. Okay, so let's say I have f of x. Say I have f of x equals x times x plus 3 over x minus 2 times x plus 3. All right, so first thing we're going to start with is points of discontinuity. Correct, points of discontinuity. Are at x equals 2 and x equals negative 3. Do either of these factors cancel? The x plus 3's, right? Which means if they cancel, this x equals negative 3 creates a what? This is a whole. And that makes this removable because we got rid of it. That means that x equals 2 is a what? Yes, vertical asymptote. And this is non-removable. Is it coming back to us? This says yes, I agree. All right, so I'm losing you guys on me. Let's take a little break. Okay? Go ahead and open your books to page 94, 95, or your Chromebook, because I did post it. Yeah, I did post it, if that's what you want. I'm going to pause this for a moment. Done, so. All right. Last thing I want to talk about is maximum, minimum, maximum or minimum. The max is the, yeah, probably. The maximum is the highest Y value. The minimum is the lowest Y value. We are also going to talk about increasing and decreasing intervals. No. Increasing and decreasing intervals use the X value. All right, so for example, let's say I have on this graph I have, how about, we'll do that. All right, I'm going to tell you this point right here is at the point -2, -2. This point is at the point 3, 3. That sounds good. And this one is at the point 5 and 0.5. So we have 3 points there. First of all, first thing I want to talk about is where the maximum and minimums are. We have a maximum at y equals 3. That's my highest y value, right? We actually have minimums at 2 points because they're at the values or the bottom part. We're going to have minimums at y equals -2 and y equals 0.5. Now here's how increasing and decreasing intervals work. When you are drawing this graph, we start by drawing down to this point. Excuse me. So if we're drawing down to that point, that is a decreasing interval from -infinity to my x value of -2. Then as I'm drawing, I continue and I draw up. So I'm increasing, right? So this is increasing from, again, my x value of -2 to my x value of 3. Then from here to here, I'm drawing down again. So this is decreasing. So I'm decreasing from 3 to what? Nope. We use our x value when we talk about our intervals. 5. And then our last one, we're drawing up again. So our last interval, we are increasing from 5 to infinity. Okay? So if you think about it, if you look at this graph, I go down, I go up, I go down, I go up. There's 4 intervals. So there should be 4 intervals using your x value. Okay? Same thing. That is what you have to do for 25 and 27. And they give you the points in the book. Okay? Any questions? All right. Now I'm done. Finish up your work.